Hey everybody, welcome to this video presentation on certificate services. This is a demonstration of a single tier PKI. Because you can have multiple tiers, you can have a 2-tier, a 3-tier, even a 4-tier, but this is the simplest, good place to start. This is a single tier PKI. That means we're going to have an environment where we have one CA that does all the issuing of our certificates. This is designed for an environment with about 300 users or computers or less. So, medium-sized to small companies can very easily get away with having a single server that becomes the root CA and then is also going to be the issuer of those certificates. Now, before we dive in, finally come up with a really good analogy. I think this is the best one yet to how this whole thing is going to work. And what I'd like to do is use the analogy of a state licensing agency. So I live in the state of Florida, and we're going to use the example of a state licensing agency for businesses. So this agency is going to be issuing licenses to businesses. So what we're going to do is we're going to pretend, okay? We're going to go back in time. Back when the state of Florida was first established, whenever that was. And we're part of the government that's been formed, and we've decided that it'd be really important that we form an agency that will license all the businesses in the state of Florida. Number one, it's going to generate some revenue because they're going to have to pay some kind of a yearly fee in order to keep that license. Now, in this analogy, though, we're going to be using an internal CA, and there's going to be no fee for those certificates. So I only pay for certificates if it's from a third party. Everything in this analogy is for your own internal certificate authority. We're not talking about VeriSign or Thought or any of those other public CAs in this example. This is all internal. But the state example is good though, right? If I need to get a license for my business, maybe it costs me $75 a year. If I don't pay my fee, the state can revoke my license. So it generates some income for the state. It also lets the state verify that you really are who you say you are. Maybe you're an ex-con or something like that, and we don't want to issue a license to your business. Maybe you're a plastic surgeon and you've had some botched plastic surgeon jobs. We don't want to issue you a license. And you always hear these stories all the time about how this doctor set up this office, or this guy was this dentist in this office, and they were practicing without a state license. Those kind of things. We want to prevent that from happening. So it gives us a way to kind of control whether a business is really valid or not in our state. And that way, when people walk into that business, they can look at that. You've all seen that. It looks like a certificate of some kind of a piece of paper. Some people will frame it and put it on the wall. And then you'll see a seal on that says State of Florida. And I can walk into a business and I can look at that license. I can see the seal that is from the state of Florida. And I get a pretty good feeling that the business is legitimate. Now, what I would still have to do, though, if I was a real aggressive consumer, is I would have to contact the state, either go to their website or give them a phone call or do whatever I need to do to find out whether that license is still valid. When I walk into a business, I have no way of knowing whether the license is in that nice picture frame that's got the seal of the state of Florida. I have no way of knowing just by looking at it that it's still current. Somebody could have that license and it could have been revoked by the state. Maybe they canceled your license for X reason, but they still have the license on their wall because they're desperate to make money and to stay in business. So what we can do is we can use this analogy of the state issuing licenses to businesses to explain the concept of certificates. Because I can't tell you how many times I've gotten this question. Why? What is it all about? I don't get it. Can you please tell me why I would even use a certificate in the first place? I work for this small company. We don't need certificates. We have no reason for them. Well, that might be true. You may work in an environment where you're so small where there really is no need for certificates. But if you ever do end up in an environment where you need certificates, I think it's an important concept to understand. So what we're going to do is we're going to pretend. And we're going to pretend that this box right here that we're drawing is our very first state licensing agency. This is the building in Tallahassee, Florida. where there's a bunch of people that were hired by the government to be employees to work in this office. Some government people, some of our legislative staff came up with some rules about what's required to obtain a license, what it's going to cost, how often you have to renew it. They're also going to come up with a list of all the different types of licenses, whether it's for a beauty salon, a barber shop, a medical office, a dentist's office, a surgeon's office, a hospital. There'll be this huge list of licenses that we can issue. And then there'll also be a shorter list of what licenses we currently issue. So this office is playing the role of that licensing agency. Now, in the computer world, this is going to be our certificate authority. So we've created a server. We've named it CA1. And what we're going to do is we're going to set up that office. And the way we're going to do that in the certificate services world is we're going to install a Microsoft Enterprise Root CA on that server. And that Enterprise Root CA will be the agency and it will be the issuer. It's going to play both roles. Now, in some larger organizations, you might actually create a top office where there's no issuing going on, and then a bottom office that actually issues the licenses. And that would be a two-tier PKI. So to make this as simple as possible, we're going to make the office that's in charge of creating all the rules and what the certificates are, that office in this analogy is also going to be the issuing entity. Now, what's going to happen is during the install of that server, when we install the certificate services, what we're going to get is a couple of basic things. We're going to get what is called a public key. And just bear with me for a minute on this concept. And then down here, we're going to get what is called a private key. And I'm just going to describe each one of these real quick. The private key does two main things. The private key can sign, and the private key can decrypt what the public key encrypts. So the public key does the encrypting of data. The private key can decrypt whatever the public key encrypts. Very important concept. But the private key also signs certificates. Now, the concept of signing, well, actually, you know what, I'll get to that in just a minute. But what's going to happen is during the installation of your Enterprise Root CA, when you go to build this office the very first time, we've got to have some information so the public knows who we are. We've got to identify ourselves to the good people of the state of Florida, right? So we have to have some method in place where they can trust us. And there is some level of trust. So we're installing an Enterprise Root CA right here on this box. This is CA1. And during the installation, we have an option to install also what's called a standalone root CA. Now, the standalone doesn't recognize Active Directory. So the standalone is a good candidate for the DMZ. So during the installation of your CA, you're going to have a choice to have a standalone root CA or to have an enterprise root CA. And if I were to make the analogy to that state-run office, you basically have to ask yourself this question. Do you want every single request that comes into your office to be manually approved? That would mean that users would submit their request to be a business. You'd look at that information, so they have to drive into the office, give you the information. You'd have to look at it. You would tell them to go home. You would look at it, figure out if they're valid or not, do some research, generate a certificate from a template, generate a license for them, put your seal of approval on it, call them, have them drive all the way back in, pick it up, and go home. Or do you want them to go to a website, make a request? You can verify it real quick because you have some other ways to verify that they're good residents of the state of Florida. Sign it, put your seal of approval on it, and then give it right back to them in one fell swoop. So the standalone root will work. It's just more administrative overhead. The Enterprise Root CA works because it's joined to Active Directory. So when your businesses come to make that request to obtain the certificate, it can be done very quickly in one fell swoop. Where with the standalone CA, it's a multi-step process. It's really kind of a three-step process you have to go through. So the benefit of the enterprise root is he can do everything in one fell swoop because he's going to know who you are because your computer will be joined to the domain. For example, if I have a server that I want to make a website out of. So let's say this is going to be member server 1, and you're going to see this in other videos coming up, and this is going to be a web server. What I can do is this web server can make a request for a certificate the same way a business would make a request for a license. So if this computer is a member of the domain, he can make his request, submit it, I can generate the certificate from a template, I can sign it, and I can send it back to him all in one fell swoop. It takes a couple of milliseconds. It's really fast. But the key to that would be all these computers are members of the domain. And in this analogy, everything is 2008 R2. In this analogy, R 2008 R2. This is 2008 R2. This is 2008 R2. And everybody's joined to the domain. I'll also bring in a Windows 7 machine here in just a minute. During the installation of your CA, the private key gets generated. The private key can sign certificates. The private key can also decrypt what the public key encrypts. A certificate will be built. The public key will be put into that certificate. And then to let the good people of the state of Florida know who we are, we're going to publish this certificate into Active Directory, which is a very important concept for this enterprise CA. So we're going to publish that information into AD. Now what's really cool about that is all my computers that are members of the domain will automatically pick up the fact that that is a trusted root CA. So my Windows 7 machine will look in his trusted root certificate store and he'll see that certificate in there automatically because of the publishing to AD. So he'll be able to see that certificate with that public key already in his local store. So he's going to already trust that certificate. He already knows about it. And he knows about it because he is a member of the domain. And he picks up on that automatically. Because he's able to look to Active Directory and see that certificate. And that certificate gets installed right into his local certificate store. So he's already going to trust this entity. So it's kind of like the state of Florida has this office that's going to issue these business licenses. And we trust that state agency kind of inherently because we know it's in Tallahassee. We know the building. We've seen it before. It's published on the website. It's verified by many other state agencies that this really is the agency that does issue those licenses. So everything within that domain is trusted because of the publishing of this certificate that contains the public key of that main agency, of that enterprise root CA. So what we're going to do is we're going to switch over to the interface and we're going to take a look at the actual installation of the CA so we can see things as they go along. So here's our computer. We can see that it's CA1. We can see that it's a member of the domain. I'm building my state agency for the very first time. It's never existed before. So I'm going to go through the wizard and I'm going to go to Administrative Tools, Server Manager. We're going to go to Roles and we're going to add the role of the CA. So again, just got to pretend this is the state of Florida. We're building that office for the very first time. This office is going to be in charge of issuing all the licenses to all the businesses in the state of Florida. In the Microsoft world for certificate services, it's our certificate server. It's our root CA, our enterprise root in this example. Now we have some options when we set up our office. It'd be kind of cool to give the people of the state of Florida a website to go to be able to request a certificate instead of driving into the office or using group policy to issue. There's some different ways to request a certificate, but this just gives me a web-based page I can go to. Now the online responder and the network device enrollment service are new features in 2008. We'll cover those in a later video. And new features in 2008 R2 are certificate enrollment web service and the enrollment policy web service. There's also a few new group policies out there for certificate services, and most all the features now come in 2008 R2 standard. It used to be that a lot of the features that we would get, you'd have to have the Enterprise Edition of certificate services, and now most of that is included in standard and enterprise. Almost everything you need is in standard now. You don't have to buy an enterprise license to get a lot of the cool certificate features. But we're going to focus on the basics for now. Now right here we have a choice to either be an enterprise or a standalone. So we have to decide. So I want every single request that comes in to be manually approved, notify the person, have them come back in and pick it up, or do I want to try to issue my certificate to the web server or to my users in the organization in one fell swoop? What would be easier? I'm just going to get rid of that right there so I have some space to work with there. Okay, so we're going to go back. Also right here, an important point would be that in order for this to be available, your computer has to be, number one, joined to the domain. If this is grayed out and you can only pick standalone, that's because the computer's not joined to the domain. You also have to be logged in as the enterprise admin to install the enterprise root CA. A little bit of a coincidence of the name there, but you do have to be logged in as the enterprise admin to install the enterprise root. And we can choose whether to be a root server or to be a subordinate. So we do have the option to install a server that becomes a subordinate to another. A couple options I could have. I could have an enterprise root, and I could then have a subordinate root. So I could have an enterprise root, and I could have an enterprise subordinate CA. And the idea behind this would be that the root would not do any of the issuing. I would install another server somewhere, and this server would be involved in the issuing, and the root would just be the top level agency that kind of sets all the rules or policies to what I'm going to be able to do. And then maybe I issue only certain types of certificates, then another server is installed and he issues certain types of certificates, then another server is installed and he issues a different type of certificates. So you can build a two-tier hierarchy that way. We could also, if we wanted to, we could build a standalone subordinate. And the standalone subordinate could live out here in the DMZ just like this and end up being a child of the enterprise. So you can mix a standalone to issue certificates out that is a child of an enterprise root. And that would be good if I want to do business with another company or to the outside world, because I don't want to expose my internal Active Directory to everybody else. So you can do some interesting mixing and mashing of CAs. Enterprise root, standalone root. Enterprise root, enterprise subordinate. Standalone root, standalone sub. Enterprise root, standalone sub. You can do all sorts of mixing and matching of these CAs, but to keep this as simple as possible, we're going to leave it just like this. We could have a standalone root in the DMZ that would have to be managed separately from the enterprise root in the CA. So we'd actually create two different management tiers here. Not that I necessarily would do that, but just to show that separation. Mainly just to explain the concept of a subordinate. Okay, so we're going to install an enterprise root. We're going to generate a brand new private key. And I just want to talk about the private key real quick. During the installation of the server, a private key gets generated. The purpose of the private key is to decrypt what the public key encrypts, and he can also sign. Now, he's going to be using some technology to do the signing, and I don't want to get too technical really in this video, but the private key signing is encrypting of a hash. So a signature is an encrypted hash, which is information that's generated by the computer and by the certificate that's built. So there'll be some type of information that's generated based on this computer, based on this key pair, and the private key is going to encrypt that hash. And he might use a technology like SHA-1 256. So we'll just put a note here that we're using SHA-1 256-bit encryption. So the private key is going to do something like this. He is going to sign this certificate by encrypting this hash. Now, he doesn't encrypt any data. He doesn't encrypt the certificate. He just encrypts a hash, and the combination of that is a signature. So basically what's happening during the install of the CA is that it's kind of like that state agency has basically said, I am the state agency, state of Florida, licensing agency, and on that license will be a seal from the state of Florida. It's kind of like saying, I'm God, and here's my seal that says that I'm God. It's a self-signed certificate. We have to start somewhere. We have to pull ourselves up from the bootstrap somehow. So this initial server has a self-signed certificate. It's a way for us to say we are who we say we are, even though we're the very, very top originating agency, the top level server. So this initial certificate is self-signed by his own private key, by taking a hash and encrypting it. That combination of ththose steps using SHA-1 256 is our initial self-signed certificate. And that's how we build our initial CA. So this is the name of your CA. So this is the name that's going to be on the certificate that says State of Florida. So we want that to have a really good name, something that can be very descriptive. We want the validity period to be twice as long as the actual licenses that we're issuing or the certificates that we're issuing. So if my certificates are going to be good for 2 years, my lifetime of my certificate for the CA that's issuing the certificate should be at least 4 years. If I want my certificates to be good for 5 years, we'll make it 10 years. Because this is the certificate for the CA that's doing the issuing. This is where the database gets written. So everything goes to a log file first and then written to a database, kind of like with Exchange or SQL. And you could follow the same best practice, right? You could have your log files on a mirror, and your database would be in a RAID 5. You could definitely do that. And we're installing IIS, so it tells us the IIS components that we need. If I wanted to add some other IIS components here, I could do that. It also warns me about the name of the CA. After I build my CA, well, first of all, you should never install your CA on a domain controller. You can do it, but it's not recommended, and it will bark at you if you go to install it on a domain controller. You can continue through and do it anyway, but it's not recommended. Also, whatever server you install your CA on, you can't change the name or change the domain affiliation, because that will mess up all your certificates. If my certificates have information about the CA that issued the certificate, and that information changes, then that invalidates that certificate. So when you pick a machine to be the CA, when you pick that building in Tallahassee to be the office to issue all those licenses, you better plan on sticking with it, because if everybody thinks the address of the building is at 555 Tallahassee Street, and your certificate's good for 5 years, and then 2.5 years later they move the building to a different location, if I go to verify that license, and on that license it says the address of the issuer is 5500, and I go to that location and they're not there, I'm probably not going to trust that certificate anymore. It would basically invalidate all those licenses that I've issued. So it's important that you pick a server, give it a name that you like, plan on sticking with it, and never change it. If you change it, you can change it. It's just that you're going to have to revoke all the certificates you issued and reissue all your certificates. So you got to think of the repercussions of changing the name or the domain affiliation of the actual CA. Just like you'd have to think about changing the address of the building in Tallahassee that issues the licenses to all the businesses in the state of Florida. So it's all very interesting, right? And by using the analogy of the state licensing agency, I think it helps it make a little bit more sense of, kind of how it would work. You can compare it to something in real life that maybe you're used to working with or thinking about. Now at this point, what it's doing is creating the private key that does the decrypting of the public key. It also does the signing. It's generating the public key that does the encrypting. It's generating the certificate, and it's putting that public key in the certificate, and he's self-signing that with his private key using that SHA-1 base 256-bit signing. It also warns us that automatic updates isn't turned on. Now, the only reason I don't have automatic updates turned on is because this is just in a virtual machine, and it just doesn't really matter. Now in real life, you got to make sure updates are turned on, because this is your CA. You want to protect it and keep it as safe and secure as possible. Okay, now the one thing I want to show you is right after the installation, if I go out to my C drive and I go to Windows, System 32, Cert Serve, Cert Enroll, I can see my certificate. So there is my certificate of my CA. And I can see there's an X.509 version 3, a unique number to identify it, and there's the signing that was used. I can see the signing that was used. I can see who issued it. I issued it to myself. Valid from, to, I made it 10 years, good till 2022. The subject information, which can be used in some other situations. And there it is. There's your public key that does your encryption. The template that was used to build this certificate was built from a CA template and some other identifying information. And that's us. That's the root. I'm the State of Florida State Licensing Agency. That's me. And I signed it myself, right? This signing that we see was done with my own private key. It's a self-signed certificate. How long it's good for, who it is, who I am, that it's okay, all the details of the certificate. So you can actually see that right there. So that's this certificate right here. The private key, we could dig in there and look at it, but you get the idea that the private key signed the public key. So that gives us that initial basic structure. Now if I go over to my Windows 7 machine and open up my web browser, I can see under Content, Certificates, Trusted Root Certificate Authorities, I can see the Enterprise Root CA certificate, the same one I just showed you, has now been brought down and copied into the local certificate store of the Windows 7 machine. We can actually open it up and look at it, and we can see the same exact details we just saw. All this information is all right here. So this is a copy of that root certificate stored right inside your local certificate store. You can also go into your Windows 7 machine and go to Start, Run, MMC, and you can add, now I'm logged in as administrator. Actually, I'm logged in as the enterprise admin, which is the full administrator on this box because it's joined to the domain. I can add in certificates, look at my computer account, local computer, and I can also open this up and look in my local certificate store of Trusted Root Certificate Authorities under certificates, and I can see it there as well. So that information is displayed in my browser and it's displayed in my local certificate snap-in on my workstation. Now if I switch back over to my CA, I can now take a look at what I just installed. So I type in MMC, and I like to create my own snap-in. I could just go to Administrative Tools and pull it up, but I'm going to add my own snap-in. Certificates, Certificate Authority, local computer. That's the main tool that controls everything. And then the other one that's very interesting is the certificate templates, which is going to give me a list of all the potential certificates that I can issue. And let me just save that to my desktop real quick. And we'll just call it Cert Tools, just like that. There we go. And that way, if I close that out, I have a nice little toolbox there that I can use to open and manage all my certificates. So this would be the state agency that's going to be issuing all the different certificates. And this would be a list of what they can currently issue under certificate templates. Now this right here can be a little bit confusing. We have two things that say certificate templates. We have under the certificate authority snap-in, under the server properties, certificate templates, a list of what we can currently issue. Under certificate templates, we have a comprehensive list of everything potentially we could issue. So in my state licensing analogy, this would be a list of all the licenses that the state could potentially issue, but maybe over time some of these businesses come and go, whatever the scenario may be, but this is the current list. If there's somebody not on the list, for example, if I look at code signing, if I look through here, ABC, and it's not alphabetical, but it's not, there we go. Code signing is not on the list. So what I can do is, if I want to be able to issue a code signing certificate, which I currently am not allowed to, as long as I have administrative privileges, I can click New, Certificate Template to Issue. I can pick that code signing template from that list. And now I can actually generate a certificate from that template. So again, a comprehensive list of all the templates I have available, the current list of templates I have available that I could build a certificate from. I really shouldn't call these certificates. These are templates that I can build certificates from. Just like the state of Florida, at that license building where they issue all the licenses to the businesses, there'd be a huge list of all the templates of all the licenses they could build, potentially, and then the list of the licenses they currently can issue when those requests come in. The other thing I want to show you real quick is on the properties of the server, we actually have what's called a extension tab. And we said that the certificate was published into Active Directory, and that certificate is published into Active Directory through what's called an AIA path. And there's an LDAP path that shows you where it's actually published. So this information that we see right here, where we publish this information into Active Directory, this publishing point is referred to as the AIA, which stands for Authority Information Access. It's one of the most difficult things to explain in this environment. So we have that set up. Then we can see the AIA, and when we installed the CA, he published his certificate out to Active Directory to this path. Now if we switch over to our domain controller, and we go into ADSI Edit and we add the configuration container, we can drill down into Configuration, Services, Public Key Services, AIA, and we can actually see that certificate. That's how this Windows 7 client knew where to go grab that. That's built into the operating system to look to this path in Active Directory to find that certificate. And that's this path that you see right here, right? It's under Configuration Container, Services, Public Key Services, AIA. And we can see the actual name of the CA. And that's where that's located at. And that's how that Windows 7 machine picked up the fact that we have that certificate published to Active Directory. So that's how it gets published and where exactly it gets published to, which I always think is good to show. Another thing that's important to note is the revocation list is also published as well into Active Directory under the CDP folder. And we can see that as well if we drill into the ADSI Edit, which we'll look at that in another video for now. So the point of showing you all that is I just wanted to point out that this certificate that's published to Active Directory through the AIA point is going to be deployed to the client, and there's no group policy needed for the client to pick up on that. This information is just made available because the client knows to look in that default AIA location, and he picks that up automatically. There's nothing I had to do to make that really work. So no group policy is needed to tell all the computers that are joined to the domain who the root is. They know that automatically. Now I still may need to use group policies if I want to set up auto enrollment, which is one of those cool features I mentioned before. If I want users to be able to go to that website with that state agency, make a request for a license and get it in one fell swoop, I would need a group policy for auto enrollment, which is one of the really cool features of having an enterprise root CA. But I don't need a group policy to tell users who the root is. Now the last thing I want to finish up with in this video presentation is basically what's going to happen. Just as an introduction, we're going to go through this in more detail in a later video. Just as an introduction, I've got a business that now wants to actually go get a license. So I have this business set up down here, and what we're going to do is make a request to go get a license for our business. So what we're going to do is submit that request to the CA. Now there's more detail to this than I'm going here in this video. This is just a quick overview. But what's going to happen is the machine has a built-in crypto engine. So built into the Windows operating system is something called the Cryptographic Next Generation, or CNG, kind of like Star Trek, or the Crypto API. And when I make a request for a certificate, it's going to build a public key, and it's going to build a private key, just like we saw before on the server. The private key never leaves the machine. We're going to generate a request for a certificate, just like a business would generate a request for a license. And in this request, we're going to include the public key. The private key stays on the machine. And some other identifying information, the URL of our website. There's a bunch of details behind this. We're going to submit our request up to the server. The server is going to look at the list of available certificates that can be issued. We're going to be looking to see if a web server certificate is on the list, and it is. So we have this big list of templates we can pull from. On the list of that big list of what we can currently issue, web server is included. Web server is on the master list, and it is something we can currently issue. So from that big list of templates, we have user, we have computer, we have web server, we have that huge list of templates. And web server is currently one of the ones that we can issue. We're going to generate a certificate. We're going to put that public key in that certificate. We're going to sign it with our private key. Now this is like the seal from the state of Florida that's going to go on that certificate that's going to be in that picture frame that goes on the wall. We're going to sign it with this private key. And remember, a signature is taking a hash and encrypting it. We're not actually encrypting the public key or any data. And then we're going to pull it back down to the server, just like this. So that's kind of the back and forth process that would occur. And that would happen in just milliseconds because that enterprise server already knows who this computer is that's making that request. Now on the website, we'd have to go through some additional steps. The server actually makes the request. Then we have to bind the certificate to the website. And then we have to require SSL on the folder that we want SSL on. And you'll see that in some other videos. But that kind of gives you the overall process. We have established in Tallahassee the building, the state-run agency that's going to be issuing licenses. We have established an enterprise root that's going to be issuing certificates. We've described how to do the installation, how it generates a public key and a private key, how a certificate is built, how the private key is used to sign that certificate. We've shown you how the certificate is published into Active Directory through the AIA path and how the Windows 7 machines and all the computers in the domain will pick that up automatically. We talked about the benefits of having an enterprise server versus a standalone. We've also shown you how a web server would make a request for a certificate that then could later get bound to a particular website based on the common name information and then require SSL in a particular folder. So that should give you a pretty good idea overall of what it means to set up a single tier Active Directory PKI. Thank you very much, and we'll see you in the next video.